Have you ever wondered how Netflix suggests movies to you based on the movies you have already watched? Or how does an e-commerce website display options such as frequently bought together? They may look relatively simple options, but behind the scenes, a complex statistical algorithm executes in order to predict these recommendations. Such systems are called recommender systems, recommendation systems, or recommendation engines. A recommender system is one of the most famous applications of data science and machine learning. A recommender system employs a statistical algorithm that seeks to predict users' ratings for a particular entity based on the similarity between the entities or simply between the users that previously rated those entities. The intuition is that similar types of users are likely to have similar ratings for a set of entities. Currently, many of the big tech companies out there use a recommender system in one way or another. You can find them anywhere from Amazon, product recommendations, to YouTube, video recommendations, to Facebook, friend recommendations. The ability to recommend relevant products or services to users can be a huge boost for company, which is why it's so common to find this technique employed in so many sites. In this video, we will see how we can build a simple recommender system in Python. Types of recommender systems. There are two major approaches to build recommender systems: content-based filtering and collaborative filtering. What is content-based filtering? In content-based filtering, the similarity between different products is calculated on the basis of the attributes of the products. For instance, in a content-based movie recommender system, the similarity between the movies is calculated on the basis of genres, the actors in the movie, the director of the movie, etc. Collaborative filtering. Collaborative filtering leverages the power of the crowd. The intuition behind collaborative filtering is that if a user A likes products X and Y, and if another user B likes product X, there is a fair bit of chance that he will like the product Y as well. Take the example of a movie recommender system. Suppose a huge number of users have assigned the same ratings to movies X and Y. A new user comes who has assigned the same rating to movie X but hasn't watched movie Y yet. Collaborative filtering system will recommend him the movie Y. Movie recommender system implementation in Python. In this video, we will develop a very simple movie recommender system in Python that uses the correlation between the ratings assigned to different movies in order to find the similarity between the movies. The dataset that we are going to use for this problem is the movie lens dataset. To download the dataset, you can use the following link: ml-latest smalls.zip file, which contains a subset of the actual movie dataset and contains, lakhs of ratings for 9,000 movies by 700 users. Once you unzip the downloaded file, you will see a link.csv, movie.csv, ratings.csv, and tags.csv file along with the README document. In this video, we are going to use the movie.csv and ratings.csv files. The first step in every data science problem is to visualize and pre-process the data. We will do the same. So let's first import the ratings.csv file and see what it contains. The script above, we use the read underscore CSV method of the Pandas library to read the ratings.csv file. Next, we call the head method from the data frame object returned by the read underscore CSV function, which will display the first 5 rows of the data set. You can see from the output that the ratings.csv file contains the user ID, movie ID, ratings, and timestamp attributes. Each row in the dataset corresponds to one rating. The user ID column contains the ID of the user who left the rating. The movie ID column contains the ID of the movie. The rating column contains the rating left by the user. Ratings can have values between 1 and 5. And finally, the timestamp refers to the time at which the user left the rating. There is one problem with the dataset. It contains the IDs of the movies but not their titles. We shall need the movie names for the movies we are recommending. The movie names are stored in the movies.csv file. Let's import the file and see the data it contains. The output looks like this. As you can see, the dataset contains movie ID, the title of the movie, and the genre. We need a dataset that contains the user ID, movie title, and its ratings. We have this information in two different data frame objects, ratings underscore data and movie underscore names. To get our desired information in a single data frame, we can merge the two data frame objects on the movie ID column since it is common between the two data frames. We can do this using merge function from the Pandas library as I am going to do. Now let's view our new data frame. The output looks like this. You can see our newly created data frame contains user ID, title, and ratings of the movie as required. Now let's take a look at the average rating of each movie. To do so, we can group the dataset by the title of the movie and then calculate the mean of the rating for each movie. We will then display the first 5 movies along with their average rating using the head method. Let's write the script. The output looks like this. You can see that the average ratings are not sorted. Let's sort the ratings in the descending order of their average rating. The output will looks like this. The movies have now been sorted according to the ascending order of their ratings. However, there is a problem. A movie can make it to the top of the above list even if only a single user has given it 5 stars. Therefore, the above stats can be misleading. Normally, a movie which is really a good one gets a higher rating by a large number of users. Let's now plot the total number of ratings for a movie. The output looks like this. Now you can see some really good movies at the top. The above list supports our point that good movies normally receive higher ratings. Now we know that both the average rating per movie and the number of ratings per movie are important attributes. Let's create a new data frame that contains both of these attributes. Execute the following script to create ratings underscore mean underscore count data frame and first add the average rating of each movie to this data frame. Next, we need to add the number of ratings for a movie to the ratings underscore mean underscore count data frame. The output looks like this. You can see movie title along with the average rating and number of ratings for the movie. Let's plot a histogram for the number of ratings represented by the rating underscore counts column in the above data frame. Here is the output. From the output, you can see that most of the movies have received less than 50 ratings, while the number of movies have more than 100 ratings is very low. Now we will plot a histogram for average ratings. The output look like this. You can see that the integer values have taller bars than the floating values since most of the users assign ratings as integer value, that is 1, 2, 3, 4 or 5. Furthermore, it is evident that the data has a weak normal distribution with a mean of around 3.5. There are a few outliers in the data. Earlier, we said that movies with a higher number of ratings usually have a high average rating as well, since a good movie is normally a well-known and a well-known movie is watched by a large number of people and thus usually has a higher rating. Let's see if this is also the case with the movies in our data set. We will plot average ratings against the number of ratings. The output looks like this. The graph shows that in general, movies with higher average ratings actually have more number of ratings compared with movies that have a lower average rating. Finding similarities between movies. We spent quite a bit of time on visualizing and pre processing our data. Now is the time to find the similarity between movies. We will use the correlation between the ratings of a movie as the similarity matrix to similarity matrix. To find the correlation between the ratings of the movie, we need to create a matrix where each column is a movie name and each row contains the ratings assigned by a specific user to that movie. Bear in mind that this matrix will have a lot of null values since every movie is not rated by every user. To create the matrix of movie titles and corresponding user ratings, let's execute the next script. We know that each column contains all the user ratings for a particular movie. Let's find all the user ratings for the movie Forrest Gump 1994 and find the movies similar to it. We choose this movie since it has the highest number of ratings and we want to find the correlation between movies that have higher number of ratings. To find the user ratings for Forrest Gump 1994, let's write the script. The above script will return a Pandas series. Let's see how it looks. Now let's retrieve all the movies that are similar to the Forrest Gump 1994. We can find the correlation between the user ratings for the Forrest Gump 1994 and all the other movies using core with function as I am going to write this. In the above script, we first retrieved the list of all the movies related to Forrest Gump, along with their correlation value using corewith function. Next, we created a data frame that contains movie title and correlation columns. We then removed all the NA values from the data frame and displayed its first five rows using the head function. The output looks like this. Let's sort the movies in descending order of correlation to see highly correlated movies at the top. Let's write the script. Here is the output. From the output, you can see that the movies that have high correlation with Forrest Gump are not very well known. This shows that the correlation alone is not a good matrix for similarity because there can be a user who watched Forrest Gump and only one other movie that rated both of them as 5. A solution to this problem is to retrieve only those correlated movies that have at least more than 50 ratings. To do so, we will add the ratings underscore counts column from the ratings underscore mean underscore count data frame to our correlation underscore forest underscore gump data frame. Let's write the script. However, we can deduce that a movie cannot be declared similar to another movie based on just 3 ratings. This is why we added ratings underscore counts column. Let's now filter movies correlated to Forrest Gump that have more than 50 ratings. Let's write the code for that. The output of the script looks like this. Now you can see from the output the movies that are highly correlated with Forrest Gump 1994. The movies in this list are some of the most famous movies, Hollywood movies. And since Forrest Gump 1994 is also a very famous movie, there is a high chance that these movies are correlated. In this video, we studied what a recommender system is and how we can create it in Python using only the Pandas library. It is important to mention that the recommender system we created is very simple. Real life recommender system use very complex algorithms and will be discussed in future videos.